Yeah, so today we are going to talk about probability and specifically sample spaces and probability. You learned about probability in 6th grade, so this is kind of the more advanced probability chapter. So first, some vocabulary. First of all, a probability experiment is when you have an action or a trial and there's different things that could happen, there's varying results. The outcome would be the different results that could happen. An event is a collection of one or more outcomes. And then the sample space is when you show all the possible outcomes. Now, the probability of an event in general is the likelihood or the chance that it's going to occur. So if you flip a coin, your chances of getting heads is 1 out of 2. There's a couple of different ways you can write probability. So you can show it as a fraction. You can show it as a decimal, or you can show it as a percent. Okay, so those all mean the same thing in probability. If it doesn't say, it doesn't really matter how you show it. I always use the rule, if there's fractions in the problem, write a fraction as the answer. If there's decimals in the problem, write decimals as the answer, and so on. So probability of event is how likely it is to happen. Now, heads or tails is a pretty simple example, but the way that you actually do the math, if it's a little more complicated than that, would be this here. Now, theoretical probability is what, in theory, should happen, right? So it's not that you actually tried and here's the results. It's, okay, in theory, using math, using the math involved in probability, here's what should happen. Now, is it going to happen? Definitely, of course not. Especially considering the theoretical probability becomes more and more accurate the more times you do something. So if I flip a coin 6, let's say 6 times, will I definitely get heads 3 out of those 6 times because that's 1/2? No. I could possibly get 6 heads. I mean, you don't know what's going to happen. Now, if I were to flip it 1,000,000 times, I should be a little closer to that half. It's not going to be perfect, but the more I do it, the closer I should most likely get to this theoretical probability. Okay, so theoretical probability, you put on the top of the fraction the number of favorable outcomes, and a different way to think of that is what you want. So what I want is heads. Heads is there once, right? There's only 1 heads. And then the bottom is the total number of outcomes. What's all the different possibilities? Well, when I flip a coin, there's only 2 possibilities. It's heads or tails, okay? So the top is what you want. The bottom is everything that you can possibly get. Okay, so another example would be like a spinner, yeah? So if I had a spinner and it looked better than that, and I were spinning and there's 4 spaces, and I'm saying what's the probability that it's going to land on the 2? Well, the 2's there once, and there's 4 possible options, so 1/4. Okay, those are pretty simple examples that you may have done in 6th grade. I'm going to come back to this one in 1 second. Experimental probability is when you actually do it and you show what actually happened. So it's based on the trials. It's based on actually trying things out. Now, geometric probability is when you're trying to find the probability of something that involves a geometric shape. So that spinner didn't really, because it didn't really have much to do with the circle. But let's say you have, we're going to do one of these in a sec, but let's say you have this square here, and you have this circle on the inside of the square. And what you want to know is if you're definitely going to, let's say you throw a dart, and you're definitely going to hit inside the square, what's the probability that you will hit inside the circle in here, right? So you would have to use formulas. So you would have to use the area of a circle and the area of the square, which we're going to do pretty soon. Okay, so that's geometric probability. It's just applying the mathematics of probability to geometric shapes, or vice versa, applying geometric shapes to probability, however you want to think of it. Okay? All right, complement of an event. So complement, in this case, is really the probability of it not happening. Okay? So to find the complement, which is, you write it like this, to find the probability of the complement of event A, whatever event A is, flipping a coin, spinning a spinner, you do 1 minus the probability of event A, which makes sense, right? So if I go back to that spinner idea, the probability of getting this is 1 out of 4. The probability of not getting it is 3 out of 4, right? Because there's 3 other spaces. And sure enough, 1 minus 1/4 does give me 3/4. Okay, another example is if the probability of something happening is 3/5, the complement, right, the not happening probability is 1 minus 3/5, which is 2/5. Okay, so let's do some practice with this. So number 1 says a stack of cards contains the 13 clubs from a standard deck of cards. You pick a card from the stack and you flip 2 coins. So all we want to do is just list what could happen, right? Well, there's 13 clubs there, so how many different options are there? There's 13, right? So 13 different options. Okay, let's go to flipping 2 coins. If I flip 2 coins at the same time, one of my options is I could get 2 heads, yeah? I could also get 2 tails. I could also get a tails and a heads, and finally I could get a heads and a tails, which is different because I got the heads on the other coin. So probability-wise, it's different. It might not matter if you're just saying like, you know, I want to get 1 heads in general, but we'll deal with that later. So these two are two different outcomes. Okay, so I have 13 possibilities here. I have 1, 2, 3, 4 possibilities here, which means I have a total of 52 possibilities. I would multiply those together because if you think about it, I could get an ace and 2 heads. I could get an ace and 2 tails. I can get an ace and tails heads. I can get an ace and heads tails. That's 4. Now I go to the 2. I can get a 2 and heads heads. I can get a 2 and tails heads, so on. So instead of listing them, every single thing out, this is fine for me. So these are the 4, and then the 13 is really, you could say, like ace through king. Okay? Let's look at number 2. You spin a spinner with 1 through 5, and you roll a die. All right. So you spin the spinner. How many options? 5, right? We can get 1, a 2, a 3, a 4, or a 5. And then we roll a die, there's 6. So we can get a 1, a 2, a 3, a 4, a 5, or a 6. So since there are 5 options for the spinner and 6 options for the die, that gives us a total of 30 different outcomes that could happen, right? I can get a 1 and a 1. I can get a 1 and a 2. I can get a 1 and a 3, and so on. 30 different options. Okay. When two tiles with numbers between 1 and 10 are chosen from 2 different bags, there's 100 outcomes. Find the probability that the sum of the 2 numbers is not 10 and the product of the numbers is greater than 10. All right, so this should get fun. Sometimes you run into problems where you can't list everything. I mean, you could, but you'd be here all day, right? And so sometimes it's actually easier to figure out the complement, and sometimes it's easier to figure out the actual event. So let's do the first one. So the sum of the 2 numbers is not 10. Well, that's going to be a ton of numbers, okay? So in this case, let's actually find the sum that is 10, and then we'll just use our complement. We'll use our complement formula, and we'll go ahead and subtract our complement from 1, and that will give us the probability. Okay, so we want the sum not to be 10. Let's do the sum of 10. So there's tiles between 1 and 10. So one option is 1 and 9, right? That would give us 10. So you want to think about all the things that could happen to give us a sum of 10. We could also have a 2 and an 8. We could have a 3 and a 7. We could have a 4 and a 6. We could have a 5 and a 5. Now, I don't have to flip the 5 and the 5. Like a 5 and a 5 is the same thing as a 5 and a 5 because they're the same. But the other ones we do have to flip. So I could also have a 6 and a 4. That's different from 4 and 6 because they happened in 2 different bags. I could have a 7 and a 3. I could have an 8 and a 2. And I could have a 9 and a 1. So those are all the possibilities of getting 10. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 possibilities. Now, how many total possibilities are there? Well, there's numbers between 1 and 10 in each bag, right? Which means there's 10 options in the first bag, 10 options in the second bag, 10 times 10, that gives us 100 total outcomes that could happen. So that would go on the bottom. So the complement, So what we want not to happen is 9 out of 100, which means I'm going to subtract that from 1. Right, and I can use a calculator or convert this to 100 over 100, and my answer would be 91 over 100, or 91%, or 0.91. So that's the probability of not getting a 10. Pretty good. Okay, let's look at B. The product of the numbers is greater than 10. So, same thing. I think that if you think about it, the product of the numbers being greater than 10 that's pretty high probability. That's very likely to happen. So instead, we're going to find the complement. We're going to do which ones would give us a probability of 10 or less. Okay, so go ahead and pause the video, and I want you to list all the possibilities that could happen that would give us a probability less than 10 or equal to 10. So for example, one of them would be 1 times 9, right? That would give us 9, and so on. Okay, so pause the video, see how many you come up with. Numbers where you pick 2 numbers out between 1 and 10, and you get a product 10 or less. And then hit play, and let's see if we got the same thing. Okay, so here's all your possibilities. Go ahead and take a look at that. Pause the video if you'd like. When you count them all up, there's 27. Okay, so there's 27 ways that we can get a product of 10 or less. So, since there's 27 ways out of 100, that's the complement, right? That's not what we're looking for. But if we do 1 minus that, that would give us the complement, which is going to be 73 over 100. I'm sorry, that would give us what we're looking for. So 27 out of 100 is the complement, right? Because we want greater than 10. We found 10 or less is here, so greater than 10 is here. So 73%, 73 over 100. All right, let's take a look at number 4. Number 4 says, at a school dance, the parent sells pizza slices. The table shows the number of pizza slices that are available. A student chooses a slice at random. What's the probability that the student chooses a thin crust slice with pepperoni? Okay, so probability is what we want over everything we can get. So what we want is a thin crust slice with pepperoni. Well, if I look on here, thin crust with pepperoni is going to be right here, right? So that means that my top is going to be 34. Now everything I can get would be all the pizza, right? So there's a whole bunch of pizza on this table. So I would have to add those up to see the total. So 34 and 36 is going to give me 70. 12 and 8 is 20, so 70 plus 20 is 90. And then I can go ahead and simplify that to 17 over 45. All right, so what you should do now is go ahead and move on to the next video, and we'll do this last page on the next video.